All right, students. So this is going to be a very short lecture, but a very important lecture because what we are going to discuss in this particular lecture is essentially something that most of the books have not specified at ninth and 10th standard in physics. You will see, certainly, as the name here, you can see basic units versus derived units versus compound units. Okay, so although you will see basic units and derived units in almost all the places in most of the books, you will certainly see compound unit mentioning also, being mentioned also. But then compound units and derived units, basically they appear to be same. Or are they really same? If they are same, then why are we using different names for them? So if we are using different names for them, is there a difference between them? If there is a difference, what is that precise difference? So essentially it is the comparison of this derived and compound units that we are going to discuss more importantly in this lecture, which will give you a very good idea of how to give examples when the question comes, what are derived units and in what way are they different from compound units. Okay, so these are the things that we are going to discuss in this lecture, and we will also discuss a few other things. Okay, so let us begin with the actual stuff. Okay, so let us discuss something which is known as the basic unit. So this will not take much time because basic units are the easiest to understand. Remember, whenever we are talking about unit, we are talking about units for some physical quantities. Okay, so when we, let's say, talk about mass. Okay, so mass is a physical quantity. Okay, because we can measure mass. How do we measure mass? We measure mass in grams, we measure mass in kgs, we measure mass in let's say centigrams, milligrams, and so on and so forth. Okay, so what is the basic unit? The basic unit is gram. Okay, so why is it called the basic unit? Because you see, it has, it gets its source from its own existence. Okay, it is not like it has been taken from somewhere else. Let's say, for example, if I take the example of velocity, for example. Okay, let's take the example of velocity. Now velocity, just like mass, is a physical quantity. Okay, so it will have its own unit, but you will see that its own unit does not have its individual existence. Like we have over here, mass is represented by gram. Now gram has not been taken from anywhere else. Okay, gram has not been taken from meter, gram has not been taken from second, gram has not been taken from kg. It has its own individual birth and existence. Okay, whereas velocity does not have its own unique unit. It has been taken from a unit of displacement, and it has been taken from the unit of time. Okay, so when, as we all know, meter per second is the unit of velocity. So can we say that meter per second is a derived unit? It's certainly not a basic unit, because basic unit, as we understand, they have their own individual existence and they have not been taken from anywhere else. Like, it's not a combination of a number of units, it's a singular individual existence of a unit. Okay, so mass, grams, is a basic unit. Similarly, when we say time is a physical quantity, so what is the unit of time? Seconds is the unit of time. Okay, which is represented with a small s. So can we say that S is a basic unit? Yes, S is a basic unit. Is G a basic unit? Yes, G is a basic unit. Of what? Of mass. Okay, so these are basic units. When we talk in terms of compound and derived units, please understand, compound and derived units are mostly same. Compound and derived units are more or less same, except for one major difference, which I am going to tell you now. So let's say, for example, now if I erase this particular portion of basic units, since we have understood what are basic units, I'll now take up two examples. Okay, so one is velocity, which is meter per second. So this is the unit This is the physical quantity. Okay, so now I'm going to write something which is called force, which is also a physical quantity. Just like velocity, force is also a physical quantity. Okay, so what is the unit of force? So let's say, for example, if we don't really know the unit of force, let's say that force is the formula on the right hand side. I'm going to write formula for force is mass into acceleration. So mass is expressed in kgs and acceleration is expressed in meter per second square. Okay, so if we let's say have a look here, the unit of force can be kg meter per second square. Now please have a look here. I will write kg meter per second square. Okay, so this is a unit of force, this is a unit of velocity, this is also a combination of 1, 2 and 3 units. This is also a combination of 1 and 2 units. So as we can see here, this unit is also a combination of a number of units. This unit is also a combination of a number of units. Okay, they are not singular, they are not having only meters or only seconds like basic units. They are different from there. They have been taken from different units. Okay, so can both be classified as compound units? Yes, both can be classified as compound units, but both cannot be called as derived units, because you see, essentially the difference, it is here that the difference of this compound and derived unit comes. You see, compound units, essentially they are derived units, they are derived units, but they do not have a unique name. Now what do we mean by this? We will understand the meaning of this once we write the detail of derived unit also. So let's say they have a unique name. Now let's understand what this means. Compound and derived units, the very first point that you have to understand is that both compound as well as derived units, they will be formed by taking a number of different basic units. Okay, so like I gave you this example and this example, both these units have been taken from a number of other units, number of other basic units. Like for example, this has been taken from a basic unit of meter, and this has been also taken from a basic unit of time, which is seconds. Okay, so when you combine two basic units, you get meter per second. Okay, when you combine three different units, basic units, you get a compound unit. Okay, so these are both compound units, but not both of them are derived units. Why? Because as the definition here says, derived units have a unique name. Now what is that name? You see, you can't really give a name to this. Meter per second is going to be called as meter per second only, but you can call this particular unit of force as something known as newtons, which is also a unit of force. Okay, so most of the times when you discuss the unit of force, most of the times you say that the SI unit of force is Newton. Okay, so Newton in itself is only a singular word, but the actual unit behind Newton is this. Okay, which is a combination of 1, 2, 3 basic units. Okay, this is also a combination of 2 basic units, but does it have a specific name? No, it does not have any unique name. Okay, so this, which does not have a unique name, will be known as a compound unit, Okay, whereas this, which is also a combination of a number of basic units but has a different unique name also, this will be called as a derived unit. Okay, now you see, this will give you a much better clarity. There are various other examples also. You can now, after you go through this lecture, I'm sure you will be able to sit down and find out a number of other derived units and compound units also. But first, let us have a very thorough understanding of this, because most of the books have not mentioned this difference. You see, both compound units as well as derived units will be taken from a number of basic units and then they will be formed. Okay, so this is the similarity. Whenever you look at a number of different basic units put together to form another unit, you will say that they can be compound units, they can be derived units. Okay, because both derived and compound units have been taken from basic units only. Okay, but when you are asked the difference, what is the difference between a compound unit and a derived unit, then you will say that compound unit will not have a unique name attached to it, whereas a derived unit will have a specific name, and usually that name is behind the name of a particular scientist, whoever may have worked upon it. Okay, similarly, let's take up another example. So if let's say we take up an example of pressure. Okay, so let me just give you another example for better understanding. Let's talk about pressure. Now pressure is also a physical quantity. It will also have its unit. Now let's see. Pressure has a formula, force per unit area, which is force upon area. So unit of force is kg meter per second square, as we just saw, upon area unit is meter square. Okay, so this meter and 1 meter here gets cancelled. So essentially you get the unit of pressure as kg. So this kg, and then meter is in the denominator, so you write this meter, and then obviously second square is already in the denominator, so you write this. Okay, so kg per meter second square. Okay, this becomes the unit of pressure. Now look, has it been formed from a number of basic units? Certainly. Kg is the unit of mass, meter is the unit of distance, second is the unit of time. So there are different basic units which have been put together, combined together to form the unit of pressure. Okay, but does it have a specific name also, a unique name also? Yes, it has a name of Pascal, after the famous scientist Pascal. So it has a unique name, it has been taken from a number of basic units. So which category will it come under? Will it come under compound or will it come under derived? It will come under derived unit. Okay, so you can say that this will be a derived unit because it has a unique name also. Okay, wherever you will find a unit which has been taken from a number of other basic units and has a unique name also along with it, then you will call that as a derived unit. But if you have a unit which has been taken from a number of basic units but does not have any other unique name, then that will be classified under compound unit. Okay, so essentially the common thing between them is that both will be taken from basic units only, put together, combined together, but then if it gets a unique name, it becomes a derived unit. Okay, that is the basic idea behind the difference of derived and compound units. I'm sure that you will have a much better clarity now, and you can serve a number of examples if asked. Okay, now coming to that portion that I wanted to discuss, there's a small idea that I wanted to give about the action and the reactionary forces. Okay, so let's say for example, this is a example that I saw in one of the books, so you can have a look here. Let's say for example that we have a thread or a very thin rope, let's say for example. Okay, so it's a kind of a thread, not very thin thread, but a relatively thick thread which will have some mass. Okay, so usually when we talk about let's say a bob hanging with a piece of a a particular length of a thread, usually we say that the thread is having negligible mass and so on and so forth, but that's not actually the truth. Okay, usually you do have some mass attached to everything. Okay, every physical quantity will have some mass or the other. Okay, so we are considering a relatively thick thread, mota thread, okay, which is hanging like this. Okay, so you see, the first assumption that we will make is that this thread has uniform mass distribution. Uniform mass distribution. What does this mean? This means that from here up to this point, the entire thread has equal distribution of mass throughout its body. It's not that over here it is thicker or has more mass and at this position it has lesser mass. No, the mass is uniformly distributed. So the moment we say uniformly distributed, the center of gravity falls right in the middle somewhere, geometric mean. Okay, so if let's say for example we have the full length of the thread as L, so you will say that this is L by 2 and this is L by 2. Okay, so this portion is L by 2 and this portion is also L by 2. Okay, so this becomes the midpoint. Okay, now what I wanted to tell you here about here is that there are three different positions that we will take into consideration, A, B and C. Okay, and we are going to determine how much weight or how much tension is there in the thread because of the weight of the thread. Now please understand children that there is no weight hanging to the thread. Okay, the thread is only hanging freely under gravity, certainly, naturally. The thread is having some mass, gravity is pulling it, so therefore m into g will be the product of mass and gravity, which will give you the weight of this particular thread. Remember, the thread is quite thick, it has a relative mass. Okay, it's not that it has negligible mass, it has some mass. Okay, it is the center of gravity over here, right in the middle, because the mass is uniformly distributed. So if somebody wants to ask you what is the weight or what is the tension in the thread at this particular point over here, and somebody asks you what is the tension at this particular point here and what is the tension at this particular point C here, so will these tensions be different? Will they have tension or there will be no tension? So that is the question. Okay, so let us see how we can answer this question. You see, when we consider, let's consider that top part over here, which is the C part. Okay, so tension at C part is what we are going to discuss first. So you see, when we discuss about the tension in this portion over here, it is going to be because of the mass of the full thread. Okay, because remember, this point C over here is right at the top of the thread, and it is this point on the thread which is actually experiencing all the weight of the thread, because most of the 99.9% of the mass of the thread is hanging below this point. So this point is going to have the maximum weight which is going to be pulling that part of the thread. So we can say that the tension over here is going to be equal to the entire weight of the thread, which is going to be mg. But when we talk about the tension at point B over here, the logic here is that when we talk about the tension at point B over here, this tension is not going to be caused because of the weight of this upper part of the thread. Why? Because usually the pulling force is only the weight of this half part of the thread. So what is the weight of half of the thread if the weight of the full thread is mg? It is going to be mg by 2. Okay, so we can say that mg by 2, or half the weight of the thread, is going to be the tension at point B. Similarly, when we talk about the point A over here, which is the last point over here, the last point on the thread, so this point is not going to experience any tension because there is no mass of the thread which is trying to pull this particular point below. There is no mass. This is the last point on the thread. So there is no mass which is pulling this. Therefore, the tension because of the gravitational pull at this particular point is going to be negligible, or let's say theoretically zero. Okay, so that is the idea, that is the concept that you should always keep in mind whenever you talk in terms of the tensions. So we always say that there is a tension in the thread because of some weight attached and so on and so forth. So here the weight is not attached. I have given you the basic idea of why the tension gets generated. Tension is some kind of a pull, some kind of a strain that the thread is facing. Why should it face it? It should face it because of some force. What is that force? There is no external force. The only force is because of the weight of the thread, and the weight of the thread is different at different places. The overall weight of the thread is acting at the center. Okay, so at different points the tension will be different. I hope you have got a fair bit of an idea of how this logic works.